Okay, so this is a brief demonstration of using the Erudine Behaviour Engine. What we've done here is configured a simple data source. If we click on that and have a quick look at some of the data, you can see this data here is XML structured and laid out as a graph, so it's generally visible to the layperson. It's used to what we're seeing on most data viewing tools. As part of the knowledge model, we've created two nodes here that will strip that data down to just the vehicle and positional information and then pass it on to the next node. So let's have a quick look inside this first node here. If we run some data through that node and have a look into it, what we can see is the trimming of just elements of the data that are here and below. So if we look at the outputs of that individual graph, we have some simplified, cleaned up data. Again, that's one of the common and very quick tasks you'll want to do when processing systems take data from external sources. That output is then being passed into this second categorized vehicle node, so let's have a quick look in there. What we see when we're in that categorized vehicle node, and we have no more existing behavior in there, is the Rolodex you can see here of test cases. We've got our first situation source, which is about vehicles being bad. So let's make some behavioral decisions about that vehicle. So that vehicle can have additional attributes changed to its data. So if we classify that vehicle, and we classify that vehicle as dangerous because it is. Then what the system requires us to do is to provide a justification. So we are saying here, because there is a vehicle, because that's something we require to be able to attach this link to it, because this is a vehicle, it is classification of dangerous. The system is happy and lets me have the accept button for that new behavior. And when we accept that behavior, what we can see now is the outputs of this node for this test case, vehicles are bad, is calling this vehicle dangerous. Interestingly, we have a working system here, and if we go to other test cases in the system, they're also being classified as dangerous as well. What we now want to do, and interestingly while we're on this second test case, is we now want to create counter conclusions to this existing test case. So what I've got here is data where the speed of this vehicle is 0. This is a safe vehicle because it's a parked car. So if we change our conclusions here and say rather than dangerous, I'd like this instance of this test case to be safe. What the system's now going to do is say, okay, if you want that to be the case, you have to provide me some more information because I don't understand why. So what it's done here is it's given us our original test case and said, you said whilst looking at this data that this vehicle was dangerous. What you now want to do, if I make it a bit bigger, is use this second test case to say this vehicle is safe, but I don't understand why. What I can do with the system is say, well, because this vehicle has a speed of 0 and it's the value that's 0, that's the reason why this vehicle is safe. The system is now happy with that and will allow me to accept that behavior because no other tests have been broken by accepting that behavior. If we now want to carry on and we go back and have a look for a third test case, we can find a vehicle moving away from us. So if we again look at this test case and say, well, because this vehicle is travelling right and it's on our right, it's going away from us. Equally, that would be true if it was on our left and travelling left. It's already past our position on the road. So we'll call that a safe vehicle as well. Again, what the system's now going to do is, if we have a look at that in more detail, again bring up the original test case and say that was dangerous and you are conflicting against the original test case, not the one with the speed of 0. And if we have a look at the detail of this test case, we can see that's our new test case, and the system does not yet understand and will not give me the accept button, does not understand how to make this one safe. If we now drag a binary constraint and say, well, because this vehicle has a direction, and because this vehicle has a relative position to me, and because I'd like a binary constraint between that right position and also this right position, and I would like that binary constraint to be equals string we'll use for now. The system says, okay, I now understand if you see a direction of something with a label and a relative something with a label, and those two strings equal each other, then I'm happy for this safe condition to happen here. We can now accept that behaviour, and the system has now been trained on 3 different test case scenarios. So if we now go back and have a look at what the system's done in the background there, because all we've shown it to that point is taking test cases. If we now go back to our model and have a look at the design of that test case for those vehicles, what we can see is the system's created for us a decision tree. If we look in detail at that decision tree, what we will again find is the logical construct it's created here is, if there was no vehicle, I haven't yet been trained on what to do. So we have a warning that there's a test case I haven't created yet, because I haven't passed it a situation without at least a vehicle in it. What the system now, however, says down here is, if I see a vehicle with a position with a speed of 0, then that vehicle is safe. If I see, and you'll see in there the condition that we created for the more complex test case of, if I see a position with a direction and a relative position where they equal each other, I now also know to regard that vehicle as safe. Otherwise, in all conditions otherwise, that vehicle is regarded as dangerous. Now importantly, what we see here is we see tests. The green colour coding here is indicating there is a test for every single one of these leaf endpoints in the decision tree. So this is test-driven development where I haven't had to produce a line of code. The system is working entirely on its own from a data-driven perspective, and more importantly from a test-driven perspective, to come to the defined outcome. So that's how you can use the behaviour engine to generate a working system, and hopefully if you have any more questions, you can have a look at the Erudine website or some of the other webinars to help you understand how that can be useful in your business for developing software and systems quickly and in a tested mechanism first. Thanks for watching.